Okay, so I guess we can start and wait for other people to join. Hello, everyone. Thank you so much for joining this Wednesday morning. And so I'm Stefania Mascolo, a project coordinator at EuroCities, and today I'm joined by my colleague Hermione, and we are together going to host this session. EuroCities is, in fact, the organizer of this webinar. We have invited you today to join to focus on the early. Let's have the first slide, please. Thank you. We have invited you today here to address and showcase the progress, lessons learned so far within the Neutralpath project. Within this European funded project focused on positive and clean energy districts, EuroCities is leading on the capacity building program for cities, the policy work, and the collaboration at European level. And so today we have invited you to showcase and deep dive a little bit into the progress of the city of Dresden, which role within the project is Lighthouse City. So we are going to address the concept of positive and clean energy district and its role to the overall goals of climate neutrality in the city of Dresden. And specifically, we are going to address different aspects of positive and clean energy districts. So we are going to try to give you a little bit of the different perspectives to how this concept of positive energy district and PCEDs, shortened, can be a important component to achieve climate neutrality in European cities. And we are going to do it through different aspects and components. We are going to start with the technical dimension, especially related to the energy solutions in the built environment with Professor John Grunewald from the city of Dresden. Then we are going to address as well the social dimension of positive and clean energy district with our speaker Luke Bosev, project manager from the city of Dresden. And so here we are going to look into the specific approaches to citizen and stakeholder engagement and how they contribute to positive energy district. And finally, we are also going to address how within the Neutralpath project, 3 years into the project, the replication methodology is taking shape to support other cities to, of course, replicate and scale up these solutions at European level. Before entering into the technical components, we will leave the floor to our project coordinator, Cecilia Sanz, who is going to give us the overview of these European funded projects, the timeline, the cities, and of course to give you, since we have a wide audience today, a little bit more insights on what is a positive energy district, what are the key sectors, the goals, and how, as I was saying, this positive energy district really can support European cities to achieve their climate goals. And of course, we will have also a specific introduction from Minan Wu, the coordinator of the project from the city of Dresden, to have a overview of how the city is progressing into the project and how this implementation is supporting overall the city of Dresden as mission cities and their climate goals as well. So this is the agenda. I hope the components and the different aspects that we are going to address is clear. Of course, that at the end of all presentations, we will leave the floor to you, to the audience, to hear about your experiences as a city, as a professional. What do you know? What is your experience as well, if you have any, with positive energy district? And to warm you up a little bit, we have prepared a little quiz that Hermione is going to focus on. So now I would invite you to yeah, to take your phones and and access the QR that you can see on the screen. So we can start with a little quiz to test your knowledge on positive energy district, and we will start later with the presentation. So I leave you on in the hands of Hermione. Floor to you.
Thank you, Stefania. Hello, everyone from my side as well. So if you can scan the QR code, or also our colleague John has posted the link in the chat, so you can also follow that. And once we are ready, we can join the quiz. So you can also use this QR code. As well. So I hope everyone is in.
Yes.
Okay, so I think we can start. So the first question that we would like to ask is, from a scale 1 to 5, how familiar are you with positive and clean energy districts? And we can see some answers already. So far, people seem to be quite familiar. It's nice. Okay, quite familiar, I would say. Okay, that's really nice. So we can move on to the next question. Is your city implementing positive and clean energy districts? Yes, no, but maybe it's in your future plans. Maybe you have already done so.
Yeah,
Here
amazing. Yeah, great to see that we have many participants who do not have experience with it, but would like to do it in the future. Yeah. So hopefully we can provide some insights.
So, and then the next question is, from your perspective, what could be the main challenge of implementing a positive and clean energy district?
We know there are many, so just pick one.
Yes, funding is a big one. Bureaucracy as well, energy flexibility, climate impact. Quite a few.
We will need a follow-up webinar to address all of them, but hopefully we will address some of them today.
Okay, and then the last question for now is, from your perspective, again, what is the main benefit of implementing a positive and clean energy district? Resilience, climate goals, livable lives. Zero emissions, electric vehicles.
Local control, yeah, a big one.
Great, so we can see a lot.
I think the benefits of positive and clean energy is pretty clear to our audience today. So that's a great start for our presenters and our speakers.
Indeed. So I think with that we can start. Thank you so much, everyone, for participating. And we can continue back to the presentation.
Yeah. Thank you, Hermione. So thank you all for joining the quiz. we see that we have an audience that is pretty familiar already and has probably some expectation to the content of this webinar. So I'm happy to leave the floor to our first speaker, Cecilia Sanz, the project coordinator of Neutralpath. The word to you, Cecilia.
Thank you, Stefania, and welcome everybody for this webinar from Neutralpath. I'm going to introduce what is Neutralpath project. It's good to know that you know about positive energy districts, so it's fantastic. So I hope you will enjoy this webinar. You will learn a lot for implementing this in future in your city. So firstly, as a kind quick overview of the project, the objective of Neutralpath is help our cities in achieving this neutrality, climate neutrality, that has the objective for 2030 and aligned with all the European objectives, climate objectives of our cities. For this, we are going to work with positive and clean energy districts. We are going to demonstrate how it works. We are going to, we have designed them in a participate mode with the citizens. And these implementations will be measured, the impact of this implementation for all of the cities. We are 25 partners from different countries. These countries obviously are focused on the cities that work in our project. We have two lighthouse cities, Dresden in Germany and Zaragoza in Spain, that implement the interventions in their districts. And we have three fellow cities that work with them, learn with them, and also work with the climate neutrality in their own cities that are Ghent in Belgium, Istanbul in Turkey, and Vantaa in Finland. So with this group of partners, we are implementing Neutralpath. That we are in the middle of the execution of the project, which started at the beginning in 2023, and yeah, more or less at the middle of the project. Apart from the implementation, the proper implementation in the cities, with these positive and clean energy districts that help us to understand how different solutions converts into only one. We are working on the long-term planning of the cities. We are transforming. We think to transform our cities, and this work is being done with the 5 of our cities. We will measure the impact of these implementations and the rest of the parts, and also we work closely with the citizens through our climate neutral labs. In these climate neutral labs, we involve all the stakeholders that could be involved in this positive and clean energy district, not only the citizens, also other companies around the city that will help to implement this in the future, not only for this specific part of the project, but with working with the neutrality in all of our cities. But before working on it, only for those that maybe don't know about what is a positive and clean energy district, we have to think in the districts of our cities that implements clean solutions as energy retrofitting of our buildings, implementing different renewable energy sources there, and working with the sharing of the energy between different buildings and storing this energy. We try to reduce the global demand, the annual demand of this district, being able to provide a surplus. The intention of all of these solutions are to produce more energy than the district needs. And what we can do with this energy, we can share with other buildings around close to the district, or we can share through put in the grid for other parts of the city. So with these districts that will be able to produce energy for the rest of the city, we want to help to achieve the climate neutrality of all the city. So this is the main objective of the positive and clean energy districts, and in fact, the demonstration in this project. And where we are doing this demonstration in Zaragoza and in Dresden. We have different configurations, two different configurations of the positive and clean energy district. In Zaragoza, we have a geographical district, all concentrated on the same one. We have public buildings, tertiary buildings, and also residential buildings. This joint of different users allows us to share profiles the energy consumes, and according to the supply and demand, we can produce more energy. In Dresden, that will be later explained by my colleagues from the municipality, we have two parts on the district. We have a virtual path, and there the two parts of the city are complemented and produce energy jointly. Apart from these two cities, we are working very closely with the three fellows one, are very active in climate neutrality, and are designing the future positive and clean energy district that could be later implemented by them. And with all of these considerations and learnings, of course, we are with the type of project we have. It's important not only learn us, it's important to provide this knowledge to the rest of the community, to the rest of the cities that could be interested in implementing it in the future, and share the experiences that have been learned here to others. So this is maybe one of the aspects that I'm treating today with this meeting, with this webinar. So thank you everybody for attending, and I hope you see perfectly what we are doing in Neutralpath and enjoy with the webinar.
Thank you so much, Cecilia, for introducing the concept and giving us a little bit more of the details to Neutralpath project. So now we are leaving the floor to Minan Bu, the project coordinator from the city of Dresden, so we can hear a little bit more insight on the project from the perspective of the city. Min, the word to you.
Yes, hello. Good morning, everyone. Thank you for having me, and thank you for giving me the opportunity to talk about our project in Dresden. I'm coordinating the project here in Dresden, which has developed a concept and demonstrating it here so far. We are the core group consists of the municipality, the energy supplier of the region, and also the university and the real estate companies. So we can have a district project. Next slide, please. So I tried to make a summary of the project, and for me it is like bringing together an EU level and a local level of action, and see how those matches. Next slide, please. Looking at the EU level, there was this specific call from Horizon that supports 100 European cities to be climate neutral by 2030, and Dresden seized the day and successfully applied for this project in cooperation with CATIF, of course, and the other partners. And what we want to do is, in the end, to have like a climate city contract that brings together the whole society of the city to move forward towards this common objective to be climate neutral by 2030. And this project is one of the component towards on this pathway. We want to emphasize the citizen engagement in this city mission, and the EU also has generated support structures like the Climate City Capital Hub to support cities with the mission label. Meaning that the cities that have successfully applied, submitted the climate city contracts will get a mission label and then get specific financial support programs from the city, from the EU. And this should facilitate investment and partnerships. And of course, the project is also in line with the European Green Deal and other EU strategies. Please, next slide. Yeah, you can see here, this is the Net Zero Cities Network, and the work program from 2023 to 2025 consists of 101 million euro allocated specifically for the cities mission. And there was in 2024, so last year was were specific calls amounting to 98 million euro. For specific projects under the climate neutral and smart cities mission. So the EU has put forward a lot of money, and currently there are 8 cities in Germany and that are contributing to this mission. And I think in total it's not 100 cities, but right now there are 112 cities. So Dresden is very happy to was successful in this call. Please, next slide. You can see here that there's a lot of support that the EU has built up around this Net Zero Cities mission. Maybe noteworthy is just go to the netzerocities.eu portal. There you can get more information on that. I just wanted to show you what is in there with this picture. So please, next slide. So what is going on in Dresden? In Dresden, we have set up an integrated energy and climate protection concept in 2013. So it was approved by the city council. And this was like this concept was part of our objective to move towards climate neutrality. Sorry for the typo. And within this concept, you can see that there are lots of concepts integrated, like the power supply grid extension plan. So it was like an infrastructure planning, then mobility planning towards 2035, as well as municipal heat supply planning, which is containing as well Sachsen-Energie, which is a project partner in Neutralpath. And because Sachsen-Energie is the energy provider here in Dresden and also in the surrounding of the city. And we were also triggered by the federal law regulations to put forward a climate protection oriented heat supply planning. And this is something that is ongoing, and our project is part of it. Neutralpath is part of this. The main objective is what we are going to do right now is decarbonize the heating sector, expansion of renewable energies, and elaborate guidelines on sustainable construction, as well as convert the transport system in Dresden towards climate neutral or with a low carbon footprint. And we want to close energy and material cycles, for example, reuse and upcycling of materials. Please go to the next slide. So I want to have this short overview here so you can see the map, because Cecilia already summarized the project, the general project objective. And you can see on the map that the cities involved here are like very widespread and dispersed in Europe. And we have a lot of different situations, initial demand, and of course the solutions will be very individual. And in Dresden, when you look at the next slide, please, you can see we have 5 work packages here that is oriented towards the main ideas of this mission is to have the local citizens involved there and other stakeholders, and therefore 5 climate neutral neutrality labs have been set up in the 5 cities involved here. And we want to develop and define innovative governance strategies surrounding that, but also having a co-design and approach towards set up the this kind of climate neutral energy district, what we call positive clean energy district. And then we want to monitor and assess the performance of this district, as well as disseminate what we are doing right now, our results, as well as developing a long-term perspective for the city transformation. And I think this is one of the main challenges here, to have a long-term perspective developing from these demos. Let's go to the next slide. So in the end, we want to demonstrate that PCEDs are designed under participative and human-centered principles. There should be cost-effective and feasible solutions to contribute to the city's transformation towards climate neutrality. And this should be the basis to approach climate neutrality by 2030. Please now go to the next slide, where you can see the demo sites I want to briefly present there. So we have at the start we had 2 sites. One is Vonovia, as you can see here, which was called Site A. Then we have Site B, and now we have Site C. Why? Site A is connected to the heat, to the municipal heat network of Dresden. So it is a central heat supply system, and around, I think currently around 30% of Dresden's area is connected to this municipal heat system, whereas 60% is not connected to it, which represents Site B, because it is more or less at the suburbs, and we can't, it's not feasible economically to connect it to the heat supply system. So we have to have a decentral kind of approach there. And on Site A, we try to, it is a collaboration between Sachsenergie, Vonovia, and the university, where we develop a more efficient and a low temperature level of heat supply grid, meaning that we can reduce the energy demand of the grid and contribute therefore to a lower carbon footprint. And on Site B, it is not connected. It is there are old houses, one family, maybe multi-family houses, and there we want to have a decentral supply. But here we are now we have put it on hold because we can't finance the construction expenses of that, as this kind of social housing projects depends fully on public funding. So one of the messages I want to put forward as a project coordinator to the EU is to develop flexible financing solutions for these kind of projects, because right now we are strangled by local regulations, so we can't even approach other financing vehicles to put the investment expenses in place, because as it is a social housing project, we have to, it is mandatory to use public funding. And when the public funds are drained, we cannot develop the project further. So we have to be flexible here. So in order to have a total positive energy balance, we now adding a new site to a project which we call site C, and it is a large heat pump. It is something that we are going to discuss with the project controllers of the EU, in order to to deal with this risk and to deal with this kind of unexpected thing. I would not getting deeper to the rabbit hole here because it has a lot to do with German regulations, why this project is now on hold. Everyone that wants to discuss that with me can connect me later on. But now we think that we can now have an energy district, positive district, when we add site A and site C, because the energy output here can generate a higher export than an import. Please go to the next slide. Maybe to have a short presentation of the sites. So you can see here, site A is it is a large building, a residential block from the 70s, and more or less it needs a modernization, and we have seized the chance to modernize the energy system as well. And what we want to do is we want to permanently reduce the district heat supply temperatures there from 95 degrees Celsius to 70 degrees Celsius, having a low X system, meaning that the input temperature level should be reduced, and therefore we can have a higher efficient system. And the other stuff is also important, but I think that the most important is to reduce the district heating supply temperatures, because then we can add renewables into it. So going to the site B on the next slide, you can see here this is more on more or less a countryside picture, and the buildings are old. So this represents a large portion of Dresden's residential areas, and we have to have a decentral energy system, heat supply system here. We also need retrofitting and also using a lot of ambient temperature technologies like heat pump, etc., to have a lower carbon footprint. And this is like something that is more demanding because it's more diverse, and so we need also a more flexible system of financing of those projects. Please go to the next slide. Here you can see this is our proposal. So it's not approved yet for site C. And here you can see it's a large central heat pump that directly feeds its output into the secondary heat district heating grid there. And also because of this large capacity, we can achieve our positive energy balance. And this is something that's ongoing, and we hope that the project of the project controller from the EU can bring forward this solution from our side. So this is a very brief presentation of the sites. Could you please go to the next slide? I have there make a very short summary of this. So currently site A is relatively unchanged, and I think that this kind of low temperature district heating network we can realize there. Site B we will keep as a dissemination object in the project, because the concept is still viable, but the financing structures is something that has nothing to do with the technical feasibility of the project. And site C is something that so the site, if you look at our project, we have 3 sites, and we will summarize or add all 3 projects' energy balance into one common balance. And because we don't have one single situation in a city, therefore we have to see what kind of typical solutions we can do on each site. And then we will add all actions into one one energy balance. And this was the idea from our side. So right now we add the energy balance of site A and site C, whereas site B is not part of the energy balance for monitoring purposes. But we keep it as a project that should support the discourse in the city on how to move forward with project sites that are not connected to the district heating network. Could you please go to the next slide? On this slide, I just want to summarize that Dresden's efforts maybe can be mirrored in the several large projects that we have put forward. So one, I think that there's a strategy here in Dresden that you can see. So we started with the AU Smart City project, where it was called the Matchup project, where we deal with a single building and how to improve its carbon footprint. And then in Neutralpath, we are going into a district and looking at this interventions into the built environment from a district level. And also ongoing is the EU city mission on a climate and a neutral and smart mobilities system or district that we have that started in 2024. Also, we are doing some knowledge transfer by our project UCAN to a Ukraine partner city, and as well as now going more to provide more or less a consulting service to citizens here in the city with the NAC for Clean Cities pilot call that we also successfully applied in 2024. Yeah, please go to the final slide. I thank you all for your patience. It was a lot of things that I have to put together in a short time. I hope I didn't miss important stuff. And anyone wants to connect with me, you can see my email address here, as well as with Luke, who is also working for the municipality of Dresden. So thank you for your attention.
Thank you so much, Min, for the presentation. I know that there is indeed a lot of content already that we have shared in this two brief presentation. So hopefully by now our participants have a more clear idea of the Neutralpath project, what it is about, positive and clean energy districts, which cities are involved, which kind of components and sectors we are trying to tackle with our cities, and the overall goals of climate neutrality, and how to use positive energy district as a component for cities and European cities to achieve these climate goals. And more specifically, then we have heard from Min as well the details of how this project is contributing to a long vision, for a long-term vision for the cities, the specific sites of this positive energy district that the city is trying to implement under Neutralpath. As a reminder, before we start with the technical dimension of the project, that we are, as it was said, 3 years into the project. So today we are going to focus on the progress, the lessons learned, also the challenges. Some of them you already mentioned as well in the quiz, from funding to technical solutions to replication. So hopefully we are going to tackle different aspects of this progress from the city of Dresden. So now that our introduction is over, I'm happy to leave the floor and start with the more specific aspects and the different dimension of how to create, design, and implement the positive energy district, and specifically from the city of Dresden. So I leave the floor to John Grunewald, the professor at the University of Dresden, and with him we are going to deep dive into the technical solutions and energy, specifically energy solutions from the city of Dresden and the implementation. So the word to you, John.
Yeah, thank you very much for this invitation. So it's an honor for me to give this presentation about the more technical dimensions It is not just one technical dimensions. There are many of them. Of course, I have to limit myself here on just a few of them, which are related to this specific location. And we should be maybe a little bit careful with replication in other cities, because the technical solutions depend very much on the local conditions. For instance, the climate or other local conditions. And in early times, for instance, in the Middle Ages, people could not afford to lavish energy. They had to build in a climate adapted way. That means our traditional buildings are climate adapted, maybe in the best way already. And today, when we have the need to come back to sustainable solutions, we should keep in mind that our construction should be climate adapted as a part of our sustainability. And therefore, we can share principles, we can share methodologies, but the technical solutions cannot be multiplied or replicated very easily. So we have to be careful and take care that everything is adapted to the local conditions. This is my first remark to this. Anmin-Fu has introduced the site B, the Pillnitz-Hosterwitz site, a little bit already, so I can make it a little bit faster. The project is on hold. This was said, but it doesn't stop us. From my point of view, this is still the most interesting part of the project, because we have some degrees of freedom, and we can develop some good solutions which may be replicated in other locations in the city of Dresden and maybe in similar climates. So you see here the pictures. It's a little bit we have some free space, and free space square meters of garden give us possibilities to harvest energy. And also the buildings are not very complicated. It's I think it's quite easy to put some renovation methods forward. We have also the river Elbe, which is very nearby. So we have a quite good condition there, and I think it's an interesting project. Our targets are, of course, supply of local renewable energy, and also the reduction of emissions, CO2 and biocides. I come to this point later. Then about owners, there should be a renovation of the building without moving the tenants out, which is also relevant to the cost of renovations. And our solutions we propose to renovate buildings are done by available components. So this is not very complicated. It's quite easy to install, but should be very efficient. And this should lead us to energy transition at affordable prices. At the same time, it should open up new possibilities to develop business models for the energy suppliers, which are specific to this kind of locations. And as Anmin-Fu already said, this location is kind of typical to Dresden locations. We have 66% of our buildings which are not connected to the domestic heating network. That means we have situations like this. So it is the majority of buildings in Dresden, and therefore it should be interesting to develop some new business models for energy supply of those locations. And of course, they should be affordable, should be not too expensive, and there should be a long-term and stable operating cost. This is, in short summary, our targets. The first thing I like to mention is the method of our work involves digital twins for building performance simulation, which I think is a very important instrument or tool to be more accurate in predictions. When we talk about renewable energy, this is not available at every amount. It's most of the time it's a limited resource. And when we have to develop plans for using limited resources, we have to be a little bit more accurate in our calculations. This was not the case in the centuries before. In fossil times, we could afford lavishing energy, and I hope this time is over now, and we can come to new planning methodologies and new planning tools which take into account the limitation of our resources. So that's the reason why we use a building performance simulation to know about the energy demand of the buildings. The first assumption is that we develop geometric models like this, what you see here on top of the screen, so that we have a one-to-one picture or a one-to-one model of the buildings inside our computers, and these buildings or the building models are able to run simulations on hourly and sub-hourly basis, so that we have a quite accurate physical description of all energy flows and energy processes that go on inside and outside the buildings. The users are taken into account by user models. These are schedules which describe presence and actions of users and demands like indoor temperature and like the shading systems, the heating systems, cooling systems, lighting systems, electricity, heating demand, cooling demand, everything is included in such a building performance simulation. And then we get the energy demand on hourly, on daily, on monthly, and annual basis. And this, of course, is one assumption for developing the energy supply concept. So the next step was to take all these technical parameters from the buildings and to develop the digital twins of this quarter, what you see here. And once this is done, you can let it run, let it simulate, and you get hundreds of results. For instance, you see here in the top graphic the boundary conditions, temperatures and relative humidities of the location, and then the inside temperatures in the buildings, which are pretty much constant because we have heating in wintertime and maybe some good conditions still in summertime. Then you see here the radiation loads which are applied to the buildings, and then here some energy balances here on monthly basis, but this is derived from hourly energy balances. And then we know about the predictions of energy demand, and of course we have to compare with the actual energy demand and we did some monitoring on site and compared simulations and reality. And then of course there is the first difficulty. Some of these buildings are not used in a usual way. We have some special people in some buildings who use very little energy because they just save energy, which is not normal. And but we have to deal with this somehow. We have to calibrate our simulations to some realistic behavior, and therefore the comparison between the real energy demand and the simulation is a good step, but it's not. We need to find the right interpretation of this data and a right way to deal with. So the next step was to develop a sustainable refurbishment solution. And I introduced this solution very briefly. So this is the existing wall with plaster. Fortunately, this is not a heritage protected or listed type of building. So we have the freedom to apply something at the outside of the building. So we come up with a capillary tube system, which is also plastered, so it's inside the plaster installed. And then on top of this, we get a thermal insulation composite system. And the purpose of this system is to provide a certain temperature at the outside of our wall, which is in wintertime 20 degrees C, and in summertime the same temperature. That means in wintertime we provide some heating of the building from outside. In summertime we provide some cooling. But this is not a full heating load. This is just the base load of heating. This is provided to the building. The peak load is still provided by the radiators, the old heating system, the radiators, which are installed inside the building. And this is quite interesting. This is comes up with some benefits or some advantages. You see here the old buildings, the 5 old buildings that should be renovated if the money is there. And if we renovate from outside, the first and biggest advantage is the tenants. They don't need to move out, so they can stay inside. There is no cost in moving tenants to other places, and this makes the solution a big deal cheaper. Then the solution consists of commercially available components. There is no new development necessary, so we can use what is there on the market. And the next point is we can activate the building mass. Activation of the building mass, so the building mass becomes a thermal storage. That means we can operate a heating pump even at times when there is no heating demand. We can just store energy and have a better flexibility on the electricity side. Of course, we want to have our own electricity production on the roofs, and we want to make use of electricity as much as possible. And therefore, it's good to have some building mass as a thermal storage. As I said, there is a heating and cooling base load supply from outside, and the peak load is from inside, which comes up with the next advantage. We don't need to change something inside. And in normal cases, you have to install floor heating systems, which is quite expensive. Here in this case, we still use the existing heating system. It means this is the cheapest solution. And since we have a temperature source at the outside of the construction, there will be some heat flux towards outside, which will reduce the tendency of condensation at the surface, which is usually a big problem because then we have algae growth. If we have thermal insulation systems with no heating system at the outside, we frequently see that we have algae growth, and this is this is fighted by a mixture of biocides, and this of course causes emissions. And when we avoid this problem, we avoid emission of biocides. So then there is still one question open. How can we separate the materials after the lifetime is over? How can we recycle the materials? We started a new research project on this. So this system is still under development to make it recyclable. And I hope we can come up in maybe 2 or 3 years with a system which can be recycled in a full way so that we have a real sustainable solutions in place. The energy supply. Of course, we have this refurbishment which should be applied to the existing houses. Then the plan was to erect some new houses as well. The whole district must be connected to the external electricity grid. Of course, there should be also some charging station. But what we want to implement is first the local electricity production by PV or PVT panels. But this is standard. What we want to do new is we want to install a local heat and cold production. I call it the seasonal heat and cold storage by using the ground as a heat storage. There are ground heat exchangers which are able to exchange heat and cold with the ground. This is the source for the heat pump. The heat pump can be centralized or decentralized. This is part of the detailed energy concept. The interesting thing is how much energy can be seasonally stored in the ground. How efficient is the system? How expensive is it? Is it really, let's say, a solution which is interesting to from economic point of view? You see here we have some space. If we use this space, we can install something like this, what we see here in the picture. This comes from a different project. We have 5, 6 different locations in Germany where we work together with other research partners, where we implemented this kind of solutions already. And you see here also a simulation of this system. This is a flat collector, so we can have 1 layer, 2 layers, 3 layers, 4 layers. Here in this case, we have 2 layers. And we can also install boreholes. Then we have a vertical installation of ground heat exchangers. And these systems are able to store energy. And we can feed in heating energy in summertime and make use of this heating energy in wintertime. So that's a seasonal storage. And vice versa, we can also, if we extract heat in wintertime, we build up a cooling potential, and this cooling potential can be taken to summertime and provide some cooling energy in summertime, which is also beneficial. You see here the advantages. Of course, this is a full renewable solution. It increases the heat pump efficiency. It provides cooling and storage in one. It's ideal for so-called 5th generation of domestic heating and cooling networks. This is the newest type of domestic heating networks. And of course, those networks enable bidirectional energy flows. And it is space efficient. At least we try to make it space efficient and long-lasting. Those kind of installations should last at least 50 years. And if in place, it can provide energy independence and cost savings, hopefully, and reduce the dependency from external resources. You see here a little bit more in detail different types of ground heat exchangers. We call it the first type, which is in the first 10 meters of our ground. This is called the very shallow geothermal energy or ground heat exchangers. Then the shallow geothermal energy is up to 100, maybe 400 meters. And everything that goes deeper than 400 meters is called deep geothermal energy. Deep geothermal energy is not in our interest. In our interest is shallow and very shallow geothermal energy. And we need to know that the natural regeneration of our ground is possible to a depth of maximum 10 meters. Underneath of 10 meters, from 10 meter on to maybe 100 meters, there is no natural generation from the top of the ground. That means if we get heat from this area, from this volume, there is some active regeneration needed. That means we have to feed in heat in summertime to regenerate the ground. Otherwise, we get into trouble or get into problems after a certain couple of years. And this leads us to the seasonal storage of heat and cold. So I investigated this topic in detail because this is my favorite topic right now, my favorite research topic. And this is something that can be multiplied in different climate zones. but it should be climate zones where we have a heating demand in wintertime and have cooling demand in summertime. Then makes it sense to talk about seasonal storage. And my favorite technology is this kind of probes. You see different types of probes, and those probes are installed in most of the time in fields of, let's say, in certain distances. It looks like this. You see here a probe field. I did some systematic simulation of this kind of probes, simulation study, radially symmetric probes or models, including groundwater and soil models. You see here how it's modeled. There's a rotation axis and there's the heat flow around the probe. I just take out one of the probes from the whole field and put this into a simulation model. And then you see here the simulation model in itself. We have 7 meters soil, then we have 10 meters groundwater, then we have 84 meters of underground. In total, a length of this probe is 100 meters. And you see here the model. And what we get from model is the temperature and the moisture behavior of the ground in dependence on the extraction and the, let's say, the exchange of energy between the buildings and the ground. You see here a temperature field at a certain time point. When I analyze my results, I watch this like a movie, because at every hour we get such a picture, and when we follow hour by hour or day by day the development of temperatures and ice contents, then we can watch what's going on underground. For instance, here we have some ice content. You see this deep blue. This is already ice formation. This is something new that we use this also in a way that we have some ice formation. Partly it's not allowed, so we have to discuss with authorities about permission to do this. At least it discovers huge energy potentials, because phase change enthalpy is a huge energy. And to get more into details, we put some sensors inside this inside this volume. Here in this case, we have temperatures in 1 meter radius around the probe. The red one is the probe temperature itself. So this is here, this blue area. And then we have the soil temperatures, the groundwater temperatures, and the underground temperature in 1 meter radius. And you see here a natural behavior that happens when you operate such a system. Of course, in wintertime, we go down to certain temperatures. Here in this case, we have a freezing. We go down to -6. In summertime, we go up to about 25 to fully regenerate the ground. Here we have 100% of regeneration. That means the same amount of energy that we get in wintertime, we get back in summertime to the ground. So 100% regeneration. This saves us that we can guarantee that we arrive at the same point every year, that we have a full regeneration and the stable operation of the system throughout many years, as long we want. And I did a systematic investigation of this. So the distance of the boreholes was, the minimum was 2.5 meters, maximum 12 meters. Different types of soil, dry, moist, wet. Different energy yields from 3,000 to 30,000 kilowatts per year. One probe here, and 100% regeneration. You see here the variance, the matrix of variance. And then the task was to determine the maximum possible energy yield while observing given boundary conditions. And we have different boundary conditions that come from our regulations. The reference is respect all boundary conditions we have right now. That means no ice, no freezing, and no overloading. That means we operate the system at an average storage temperature of 10 degrees C. Then in simulation, we can ask what happens when we go do icing. That means we go down to -6 degrees C in winter time. That is the minimum temperature. Then we do some overloading. We go up to 23 degree in average in summertime. And then we combine icing and overloading and look what's coming out, how much more potential we can access, and how can we increase the energy yield when we allow this kind of boundary conditions. You see here our reference, so we respect all limitations. We have here a range between 5,000 and 10,000 kilowatt hours per year delivered by one single probe of 100 meters. Of course, if we have 100 probes, a field of probes, then we have to multiply this amount with 100. You see here, if we have a distance, you see this is the distance of probes of 5, then each probe takes 25 square meters of space. If we have a distance of 10 meters, for instance, then each probe takes 100 square meters. And when we go from one location in the city to another location, of course, we have to ask how much space is available to install such technologies. And most of the time, space is very limited. And therefore, we have to try to minimize this space requirements. And therefore, the question was, if we go to very small spaces, what about the energy yield? We see that we have a decrease of energy yield when we have smaller spaces or smaller distances than 4 meters between the probes. And then, of course, we can calculate how much energy yield do we have per square meter. This is the specific energy yield per area. And of course, this goes down because here the area goes up. And it seems that the optimum distance between the probes is between maybe 4 and 6 meters. Today, in practice, we have 8, 8.5, 10 meters. So this proves that we are not arrived at optimum. We have still possibilities to improve the technical solutions. And when we even go to icing and overloading, we see the energy yield is a factor of 3. So that's a huge potential, which is not used up to now. And that means our ground can serve us much more as an energy storage than we use it up to now. So there's a huge potential. And from our point of view, this is the only solution that can provide us a local heating and cooling supply without using burning processes like burning gas or burning Wasserstoff, hydrogen, and this is, for instance, a solution that can provide some independent energy supply in our cities. And therefore, also from economic point of view, this should be quite interesting. So my conclusions, seasonal heat storage through near-surface geothermal, shallow geothermal energy holds a great, still unused potential. This makes a difference in local renewable energy concepts for neighborhoods. This is what we try to discover. Building a renovation and energy supply concepts must go hand in hand. This is also a new approach because buildings and energy supply systems form one system. And when we treat it as one system, we can optimize this as one system. So building renovation should decrease energy demand, and the remaining energy demand must be delivered by local renewable resources. Cost-efficient renovation is crucial for increasing the renovation rates, and the buildings become active players in energy management. And of course, as I said in the beginning of my presentation, high-quality tools and simulation models are essential and should become part of future planning processes. So thank you to all of you. My email address is here. If you have further questions, please let me know.
Thank you so much, John, for the detailed presentation. I think it will be also very interesting to hear during the Q&A how the participants to the session today relate to these solutions, if from other cities they have any experience in implementing similar solution or the same ones. And we can also explore together, of course, any question that you might have until now for our speakers later. In your presentation, John, you have also mentioned how really these technical solutions, as of course the PCD, as you have said, the energy and built environment sectors are at the core of these successful implementation of the districts. But we do also have solutions that are and need to be designed and take into consideration the behavior and the behavior, of course, of the tenants and the homeowners. And this was also a point that you mentioned. And this really leads us to the next presentation that will be given by City Manager Luc Bosse from the city of Dresden. And in this presentation, we are going exactly to explore how these technical solutions must be designed, and within Neutralpath are trying to be designed and really engage with the local stakeholders and the local ecosystem. So the word to you, Luc.
Thank you very much. Just a quick question. Can you hear me? Can you see the presentation?
Yes, both, yes.
Perfect. That's amazing. Thank you, Professor Grunewald, and thank you, Min, for the very nice presentation of the measures in Dresden. I would like to extend a very warm welcome to all of you on behalf of the city of Dresden. My name is Luc Wojciew, and I'm a smart city manager for the city of Dresden. And I would like to give you a very, very brief introduction to the CN Lab here in Dresden. So, at first, we need to define what is CN Lab. CN Lab. Wow, what does it stand for? CN is obviously an abbreviation, and it stands for Climate Neutral Lab. Climate Neutral Lab. That is the name of the concept within Neutralpath, and it's basically something in between, or I'd rather say something that combines the participation and dissemination. It's somewhere in between. It kind of takes together the both concepts, the both work packages we have within the Neutralpath. Those of you who have already participated or worked for an EU project will have known that this is something very crucial and central to every EU project funded on the Horizon scheme, as much as Neutralpath is. In different projects, these citizen labs are introduced under different names, and they have different concepts. Some projects have a physical room, a physical space where all the interested people can come in and to talk to the representatives, to see some pilots, to see some texts, some presentation on the project. That is not really what we do in a Neutralpath. Our approach to CN Lab is rather structural and formal, because in terms of CN Lab, we want to build strong relationships with all the local stakeholders and to citizens. And what we want to do is to engage a dialogue between citizens, stakeholders, and city administration to get feedback, to get comments, to get all the necessary points so that we can design PCEDs, the positive clean energy districts, together and make them interesting and livable for the people. Because what I always say, I'm a smart city manager, and smart city is about citizens. Everything we do has a very big impact on the citizens. So it is only natural that a part of a smart city project is the participation where the citizens are involved, where the citizens are asked to participate, and the points gained from the feedback is then used in the designing of new positive clean energy districts. So just to frame it a bit, what is a CN Lab? It's actually an innovation hub for co-creating climate neutral solutions. In Neutralpath, we have 2 sites, and soon we will be having a third one, as Min has already mentioned. In terms of these 3 sites, the technical concepts are set. There is not much we can change. It's a part of the project, but what we can do is to get feedback on the technical concepts we are to implement or we have been implementing in the sites and learn from this feedback for designing the next positive clean energy districts. As Min has already introduced, we have 5 cities involved in Neutralpath. Dresden and Zaragoza are the lighthouse cities, and then we have 3 additional follower cities. And every single city has its own CN Lab. This is quite important. I will talk about that a bit later, but every city has its own CN Lab. And we are designing those labs as living labs for participation and experimentation. That's what I have already mentioned. So the main objective of CN Lab is to engage citizens and stakeholders, the key local stakeholders, to get involved in the designing of positive clean energy district. We also want to share knowledge because along the neutral path, we have learned quite a lot of lessons. And I always say, if we learn something, we should share our knowledge and we should share the best practice, what we were successful in, what we weren't probably not that much successful with the rest of the cities, with the rest of the project partners, and at the end of the day, with the rest of the cities within Europe, within the world, which would like to implement such concepts like PCEDs. So CN Lab is also a medium, a communication medium where we can share knowledge and best practice in the first place within the city, and then later on in the project and on the EU level. Which brings me to the core values of CN Lab. CN Lab is citizen-centered. As I have already briefly mentioned, it's a smart city initiative. We are doing this for the citizens and for the local stakeholders. So it is only natural that in the center of the focus of CN Labs are the citizens. And also all the CN Labs are locally adapted. As I said, this is very important because every city has different characteristics. And within the CN Lab discussions, we need to address the local conditions, the local problems, the local challenges. So every CN Lab is always focused on the city where it is actually being operational or implemented. It is also collaborative. We want to work together. It is the moment when the city administration connects and speaks to the local citizens, to the local stakeholders, and to the citizens, and we end up in a dialogue because we want to know the opinions and the experience of the citizens and of the local stakeholders on the concepts we are implementing. We need to be flexible because when we learn that something is not working the way it should be, we need to be able to change it, to adapt to it. And we need to be able to evolve. So once we have implemented the positive clean energy district, we should be able to transfer this knowledge to other districts of the city, to other cities, and perhaps to scale it a bit up. And this, of course, leads to the support of the city on its way to the climate neutrality, which is at the end of the day, as Cecilia has already said, the main goal of Neutralpath. So as you have understood, The main purpose of CN Lab is to co-create sustainable energy solutions with local communities and stakeholders. We have three key elements which we are using in terms of CN Lab. The first one is the stakeholder mapping. If we want to collaborate with the local stakeholders, we need to ask and answer the question, who are the local stakeholders within the city administration? And we need to categorize them. I will show that a bit later on. Then we have the governance structure. The city administration is a huge concept with a lot of offices and departments, with a lot of clerks, and we need to be able to understand which departments and offices are the correct contact people for our innovations, for our projects, for our measures, and we need to define the roles correctly. That is very, very important if we want to, let's say, make the bureaucracy, which is omnipresent, a bit more effective. And then, of course, once we have identified stakeholders and the governance structures, we create a roadmap of activities, workshops, and actions so that we can engage the citizens, the stakeholders, the people from the city administration to work together, to get in the dialogue, to make them brainstorm, to make them discuss the topic, and to get those takeaways points we need for the correct implementation in the future. So that was rather a theory on the CN Lab as a concept within Neutralpath. Obviously, CN Lab in Dresden is then a very brief introduction of what we do locally in Dresden. We have currently 2 PCEDs. We will soon have the site C. So we are focusing on the measures being implemented in Leeuben and Pillnitz. Our objective is also to support the city of Dresden on its carbon neutral pathway to the climate neutrality, which is obviously a long-term goal, and then also foster the citizen engagement through participatory processes. We have identified all the necessary stakeholders within the city of Dresden. I have just listed a few of them as good examples, but the majority of the stakeholders listed here: Technical University Dresden, Wohnen in Dresden, Sachsen Energie. Those are those stakeholders involved in the project. And we are tackling upon 3 innovative solutions: district heating, which is site A and site C; geothermal energy, as has been introduced by Professor Grunewald; and a sustainable urban design. So, enough of theory, enough of the theoretical framework, which is, from my point of view, very important. But now I would like to show you what we are actually doing. We have divided the CN Lab into, let's say, four stages, for subgroups, for subtopics. The first one is the management of the lab, and then we have developing PCEDs. Then we have capacities for PCEDs, and last but not least, we also have engagement and societal acceptance. And within all of those 4 groups topics, we have several activities somehow spread across the whole timeline of the project. So you can see that we have some expert interviews, we have some yearly meetings, we have co-design workshops, we have evaluation meetings, we have validation loops, we have peer review workshops, we have knowledge sharing, we have local events focused on the scaling up of the PCED concept, like for instance hackathons or even local demonstrations. So those are actually all the activities we are implementing in Dresden within the CN Lab. This is the practical. These are the practical activities we are doing within this framework. This is then the governance structure. I have included this chart because I believe this could be interesting to to those of you who are working for the city administrations. This is, for instance, how we do it. We have a CN lab management team, which is mainly consisting of the representatives of the city of Dresden, with the corresponding competencies, also of the Neutralpath project, because there's the piloting project in this area in the city of Dresden, and then also the citizens group representatives. And then the CN lab, within its organization, within its structure, is divided into 4 tasks. The first 2 tasks are focused on the both PCED areas we have in Dresden. Soon we will have the 3rd task force for the PCED in Beringstraße. And the structure of those task force are actually identical. We always have the technical specialist, we have the zoning planner, we have the landowner, we have the developer, we have the solution provider, and then of course the citizen group representative. So as you can see, we have all these facets, all of these key components of the participation integrated within the local task force. But then we have 2 more additional task forces focused on developing carbon neutral pathway and improving capacities and awareness. And as you can see, those topics are not only related to the Neutralpath project, but they are critical on the city level. This is bringing the knowledge of Neutralpath to the city administration. So the structure here is slightly different. For instance, in Task Force 3, we have the carbon neutral specialist, we have detailed planning specialist for action plans, we have financial manager, because at the end of the day, it all comes to the financials and to fundings. And then in Task Force 4, we have the CN strategist, represented by the city of Dresden, capacity building specialist, funding specialist, and citizen group representative. So that is like the theory, that is like the governance structure of the CN lab in Dresden. But I have talked about stakeholders. This is obviously one of the most crucial part of participation and dissemination then later on. And this is, for instance, how we have done it. We have identified all the stakeholders relevant to Neutralpath and to the topic of decarbonization and PCEDs in Dresden, and we have then categorized those into homogeneous categories, for instance, admin, knowledge institutions, civic associations, citizens, energy agencies, energy providers, ESCO. But that would not be enough, because as you can see, there is quite a lot of stakeholders, and we need to understand whether those stakeholders can support or be interested in terms of PCED in co-management, in co-development, in co-decision, or rather to be informed and consulted when something is being discussed. So that's what we did in the next step. We have assigned the stakeholder row within this map. Then we have assessed the stakeholder's power. Is it a stakeholder with a high power, or rather medium or a low power? You know, to be able to prioritize the contact with them. And then also with the stakeholders' interest. Are those stakeholders which are highly interested in the project or in PCEDs? Or are those the stakeholders who rather don't want to be involved? So as you can see, it all makes sense. We have said we have activities. For those activities, we need city administration, we need stakeholders, we need citizens. Then we have the governance structure of the CN lab. Now we have identified the stakeholders. And by the way, this is something that is not done once. This is something that needs to be done continuously. At least once a year, this map should be updated, because new stakeholders can appear, the interests or the role or the power could change, and this is something that is actually a living document which needs to be updated on a regular basis. And then at the end of the day, we have the current governance structure of CN lab, because once we know how the structure should look like, what a structure should look like, and we know the stakeholders, we can then assign the roles of the CN Lab components. So this is something I probably don't need to mention that long, but you can see that we had the role in the second chart, and now we have assigned the single stakeholders and partners which are supporting the CN Lab, which take the responsibility for the single topic. Okay, so I have introduced the idea of CN Labs within Neutralpath. I have shown you how we work with stakeholders and what is the governance structure of CN Lab. And then now I would like to show you just some hand-on experience in terms of what we have already done. Those are the activities you have seen in the first chart in here. Those are the activities that are hidden behind these points within the roadmap. And last year, we were, for instance, able to organize 2 workshops with local stakeholders. The first one was in Loschwitz and the second one in Leuben. Here in Loschwitz, the main topic was the implementation of a cold local heating network using renewable energy. So basically what Professor Grunewald has introduced. And we have had some interesting discussions on technical requirements, financial challenges, and most of all the community involvements, because we had 2 representatives of the citizens groups and organizations and initiatives, local and native to Loschwitz. We have also tackled upon the key themes like municipal heat planning and data driving solution for sustainable development. So it was like a semi-professional discussion with points, what the society needs, how it perceives the concepts, what it actually needs, what should be done. And we have been provided with feedback, which we have then used later on within the further PCED designing processes. And we have also learned that it is really important that we take the citizens on board, and that we communicate, and now I mean as the city administration, that we communicate with those citizens and citizen groups in a very transparent way, because, and that's something we tend to do in city administration. That's just how the way it is. Sometimes we tend to omit the citizens, but we have learned that the citizens are there, they are interested. They want to be taken on board, and it is therefore very important and crucial that we have these components like CN Lab to get them involved. And this is the second workshop with local stakeholders in Leuben. Here the main objective was optimizing district heating systems for climate neutrality at the neighborhood level. Basically, the concept we are implementing at Site E, as Mean has introduced. We have also had some interesting discussion on enhancing efficiency and reducing network temperatures in district heating, again, with the local stakeholders, with the citizen representatives. We have also delved deeper into the funding opportunities. We had a very interesting presentation on how such measures can be funded, which, as I've already said, is quite critical and imperative. And we have also discussed the complexity of the application processes. Again, here we have learned, and we have somehow checked that the cooperation between administration, science, industry, and civil society is absolutely critical. We need to talk to those people. We need to have the stakeholders on board. We need to have the citizens on board if we want to design PCEDs in a successful and a sustainable way. So this is like a check for us that the CN Lab, everything we have done so far, and the vision of CN Lab is correct, and it's something that needs to be done. Now I would like to very briefly mention some next steps we have planned for the CN Lab in the following months and years. We are currently developing a new set of workshops to activate the stakeholders we have identified and to make them collaborate even more. We also want to continuously identify new relevant stakeholders because, as I said, this is a process that never ends. This is a continuous process. We also, and this is of course a bit challenging, but something that is crucial and needs to be done, building strong structures within the city administration. We want to bring all the relevant offices and departments to work together and engage them in the process of identifying and developing future PCEDs. Because as I always say, the worst thing that can happen in smart city or in projects like Neutralpath is that we have a project. We implement it for 5 years, and once the project is over, then everything disappears. And that's something we definitely want to avoid. We want to bring this concept into the city administration, and we want to pass this idea of Neutralpath and the experience and knowledge we have gathered within the Neutralpath lifespan, so that it can live on in the future and it can be further developed. And that's why the last point is the identification of the city administration departments who will take over the role after the project time is over. This is also a long-term objective of ours, but we are working on it very intensively, and we need to have this fundamentally covered by the end of the project, obviously. Okay, ladies and gentlemen, thank you very much for your attention. As I said, my name is Luke Boych. If you want to reach out to me, if you have any questions, do not hesitate to reach out. My email address is lboitsev@dresden.de. I am very happy to answer all of your questions. Once again, thank you very much for participating in this webinar. This is all from my side, and I believe I can now pass the floor to Beryl.
No, just a second. Thank you, Luke. Thanks a lot for the presentation. I think that it's super clear from what you have described, that for the city of Dresden, the Climate Neutral Lab has been and is being an effective tool to not only coordinate internally within the public administration, but also to cooperate and create long-term partnerships with the local ecosystem, and also engage with the different sectors. So thanks a lot. And now, yes, indeed, let's leave the floor to Beryl from Demir, a project partner, and we are going to end the presentations with a focus on replication. So putting together everything that we heard today, how we can, for the attendees of this webinar, what we would like from Neutralpath project, share with you so far in terms of replication, different components, and the methodology that is currently being developed in the project. So Beryl, the floor to you, and if you want to share the screen as well.
Yes.
Since we are running just a little bit behind the agenda, I would kindly ask you to keep it a little bit shorter. Thank you so much.
Of course. Hi, everyone. This is Beryl from Dem Energy, and we are the leader of replication and upscaling in Neutralpath, and we are working both with the lighthouse cities and the fellow cities to identify new PCED areas in the cities, and also design PCEDs in these areas, just to have, execution-ready projects before the project finishes, ready to be executed maybe after Neutralpath as well. So here we developed a methodology for the PCED design, as I said, and the methodology is consisting of 6 phases. And the first phase is focusing on the identification of other PCED concept boundaries in the cities, because as you know, in the lighthouse cities in Dresden and in Zaragoza, already 3 PCEDs actually are being executed, but we are also trying to identify new PCED areas. So the first phase is focusing on how we can identify new PCED boundaries in the cities. And the second phase is focusing on the technology selection, identification of the tailored context-dependent technologies in each PCED boundary in the cities. And the third phase is to understand if this technology, the identified selected technologies, really fit to the district context or not. So we identify the barriers and enablers of the technologies of the solutions. And then the next phase is the calculation of the annual energy balance to identify, to understand and verify if we are really on the positive surplus energy or not in the identified district with the identified technology. And the next phase is the, accompanying this technology selection with a proper financial scheme and developing an investment plan for the PCED design. And the last phase is, if possible, to identify, to develop proposals for new regulation policies to include PCED in the maybe zoning plans of the municipality or in the strategic plans of the municipality, etc. So, as I said, the first phase is the identification of the PCED concept boundary. And we start working with at macro scale for this identification at the city scale, I may say, so macro zones and island scale. So we collect data, GIS-based data from the cities based on some identified critical PCED development critical elements, and I will provide more information soon. Then we evaluate each layer, each category, and each, as I said, the critical element in terms of economic, social, political, environmental point of view. So a kind of a multi-criteria decision analysis through a survey questionnaire that we developed. Then once all the critical elements are evaluated through the MCDA approach, we start working at micro scale, so-called micro scale. We identify potential areas at macro scale, and then we prioritize one of them to further go on at micro scale. Then we also overlay the analysis with the energy demand analysis of the district to identify the area. So at macro scale, as I said, these are the categories for the critical elements for PCED development in the city. We collect data based on resource availability in the city. The resources may be solar, wind efficient zones, potential zones, ground coupling potential, as Professor John presented in his presentation, geothermal potential, water resources, biomass, waste heat, etc. Then we also look for opportunities for PCED development in the urban macroform data, such as we look for strategies of the city in terms of new development areas, retrofitting areas, infill or transformation areas in the city. And then land use context is also very important, as you know, for the PED and PCED development. And then the energy infrastructure of the city is quite important. If any, maybe district heating exists in the city, or any large-scale thermal or electric energy storages available in the city, and in e-mobility infrastructure of the city is also quite important for our analysis. Then we also look for energy, the virtual infrastructure of the city in terms of energy, the energy services, so-called, if any virtual power plants or microgrid applications already ongoing in the city, we look for GIS-based data for this services. And also we look for the social structure of the city, again, in terms of spatial information, so the demographic data, the cooperation, let's say, if any energy community exists in the city, etc. So the main 6 categories are listed here as and their subcategories are also listed in a big list in here. These are called as PCED critical elements, analytical components, so-called, that we start working at the macro scale. So as I just explained, in the second step of the first phase for the area identification, we evaluate each of these critical elements in terms of economic, social, technical, environmental, and legal point of views. So we direct some questions to the city based on the information they provided us in terms of shape files, in terms of GIS data. And after the evaluation, we conduct a weighted overlay analysis, with the results that we collect from the MCDA questionnaire. So this is more or less technical approach for the weighted overlay analysis, that we generate rasters and we conduct the raster calculation based on the data, and then we conduct weighted overlay analysis with the weights that we collect from the MCDA questionnaire. And then at the end, as you see here, we identify some potential PCED areas in the city at macro scale. Here you may see, some of the examples from other projects. For example, in Making City, already finished last year, we conducted the same approach in terms of PED development. So in Neutralpath, we are targeting the clean concept, as you know. So we changed some parameters, some critical elements as well. So as I explained before, we first start with the data collection for each category, for each critical element, and then we go through with the MCDA questionnaire, and then the analysis results provides us a map with spatial information in this map with least suitable and most suitable PCED areas. And then after the analysis at macro scale conducted, we go on with the micro scale. We go deeper with the building features, let's say. So if the building ownership, for example, and the building use data, also the population, etc., of the buildings in the potential areas. And we overlay it with the energy demand analysis that we conduct, and in order to understand, to have a rough estimation of the energy demand of the buildings. So we understand, for example, in the retrofitting areas, we see more or less energy consumption of buildings that when compared to, for example, new development areas, etc. And this gives us a clue on the city's approach to if they are willing to work to develop a PCED in a less developed or more developed buildings. So again, you see some other examples from Making City here in the city with the overlaying of the energy demand analysis and the potential areas. We identified prioritized areas in the city to work on at the macro scale. For example, this another another example from Making City, our city, Dresden. As you see, the identified area, and then we provide some information regarding the energy consumption, demand, and also other building users, etc. And that's the identified PCED boundary here. So then we go on with when we identify the area for the PCED development, then we go on with the technology selections. Here again, we identified another methodology to define to identify the technologies. First, we try to define the ambition level of the district. If we aim for climate neutrality, let's say, or if we just aim for positive energy balance, etc. And then we developed a tool that links you to the technology packages based on your ambition level, based on your answers to the questionnaire that I'm going to show you later. And then we prioritize some technologies based on the answers of the district, based on the ambition of the district, let's say. And then, as I said, we conduct a barrier enable analysis for each technology. And we conduct the calculation of the energy annual balance. So the barrier and enabler analysis also represent the phase 3, and the calculation of the annual energy balance represents the phase 4 of our set design methodology. So to understand if we are really on positive or not. So this is the tool that we developed in Making City, first of all, for the positive energy district technology selections. But here in Neutralpath, we're going to adapt it to PCED development, which means that we will consider the climate neutrality also in the technology selections. So in the tool, you may also check the website here, and as you see the QR code here, you should register first, and then it asks you some questions, very simple questions on the ambition level of the district, on the concept boundary, if this is geographical, virtual, or functional boundaries, etc. And then it asks you questions, just yes or no questions on the resource availability, urban macroform, land usage, energy infrastructure, virtual energy infrastructure, and soil structure as all the same categories that we developed for identifying the PCED area. And based on your answers, it provides you a technology package as a result, more or less something like this. But here, lots of technologies has been selected based on the answers to just provides you a, not to provide you a quick view on as a nutshell. Then you once the tool provides you these images on the technology packages, you understand, what kind of retrofitting you should be conducting to your buildings, what kind of technologies you should use for example, solar generation, for wind generation, or biomass, whatever, and also if storage should be integrated or not, etc. Or if e-mobility is also is available in your case, etc. But we're gonna, as I said, adapt this tool to Neutralpath very soon. We are now with the cities. We are now at the stage of data collection and MCDA questionnaire, filling out the MCDA questionnaire stage with the Neutralpath cities, with Dresden, for example. The next level that will be towards the end of this year to identify the technologies. And for the calculation, once technologies are set for the district, then we can start calculating, if we are really, to understand if we are really on positive or not. For this, again, we developed another methodology. First, we define the PCED boundary, which is, in our case, mostly geographical, but sometimes also virtual boundaries. Then calculate the energy needs of the district, the energy use, so-called the energy consumption, I may say, the on-site energy generation, renewable energy generation on-site, and the estimation of the energy delivered. So what is, how much energy is delivered to the boundary from the grid or from the heat grid, etc. And then all the calculations are converted to parameter energy to speak the same language with thermal and electric, as you may know. And then we understand if the calculate balance, so we see if we are really positive or not. And as I just explained at the beginning, we will also develop financial schemes, investment plans for the identified PCED designs, technical designs. For Dresden, we will calculate the cost and the revenue data for each technology identified in the potential PCED development. And also we're going to list the non-monetary benefits as well, because these are also very quite important to be included in the investment plan to motivate the investors for the PCED development, and also meet these benefits and the costs, etc., with the appropriate financial instruments will be conducted. Maybe kind of a decision support tool can be developed to help the cities, not just the fellow cities, but also, of course, the lighthouse cities to design their PCED. And the last phase is as an outcome of all of this research for identifying PCED area, technology selections, development of investment plans, financial schemes, will be resulted for recommendation for replication and scaling as new proposal of as new policies for the city that could be included in midterm strategies, long-term strategies, and also climate neutrality strategies for the city, hopefully. So thank you very much. I hope I did not exceed so much of my time.
Thank you so much, Meryl, and I'm sorry that we didn't have more time because indeed your presentation was full of insights and it deserved maybe a little bit more time. So thank you so much to all of you for participating to this first webinar focused on the replication and all the aspects of the positive and clean energy district in our city of Dresden. If you are external to the project, you enjoyed the webinar and you want to know more and be more actively involved as well in the other activities that we have with our cities as well, we also want to invite you to stay connected with us and to join both the City Alliance of Neutralpath, if you are especially from a city or a city officer and would like to focus and collaborate more closely with our cities, with our 5 cities, And if you are more interested, let's say, in the technical aspects, then we also invite you to join our community of practice, in which we share more and we organize webinars and activities more focused on the built environment, mobility, and energy solutions. So this was a wrap. Thank you so much for participating, and see you all to the next activities. Thank you.